All right, good morning, good afternoon, or good evening, whatever time you're watching this educational video. At this very moment, we will be knowing or studying or even reviewing about impulse and momentum. And yeah, I will be presenting problems related to impulse and momentum. But before anything else, we would like to um, know or review what is impulse and what is momentum. Let's talk about first impulse. Impulse is like impulse buying. It means you have to buy without thinking, just as quick as that. So, impulse is related to that particular situation as well. So, when we say impulse, we will be using the symbol I, but in some books, they use the word, or I mean, they use the letter J in some books, but in this video, we will be using I, an uppercase I, to represent the impulse variable. And another definition of it is it changes with momentum, which will be another variable that we need to discuss later on. And it talks about the force applied by a very short time interval, like very short. Please take note, a very short time interval with that applied force. So it will generate the impulse. And it is a vector quantity, meaning it needs magnitude and direction, of course. Then the direction, talking about direction, the impulse will go with the force. I mean, the force direction. The equation in doing impulse is impulse is equal to, since we have force applied with a very short time interval, so we can just have this simple equation here: force multiplied by the delta time or change in time. That's impulse, the amount of force in just very quick time. And of course, it will generate a very, very large force in just short amount of time. Okay, so what about momentum? When we say momentum, we will be using the word like lowercase p to represent momentum. It's not rho, but it's just lowercase p. And it is described in most book as the mass in motion. Anything that moves will have momentum. For example, a train with a very large mass, it will be moving with a very large amount of momentum. And for example, a cheetah that is running with its highest speed, of course, or velocity, it will still generate a very high momentum. Okay, let's talk about momentum more. When we say momentum in straight line or in linear motion, it is just the product of objects velocity and mass. Take note on this. And it is also a vector, meaning just like impulse, it needs magnitude and direction. Relates to mass. The more inertia or mass or velocity, the higher the velocity, higher the inertia, of course, the higher the momentum. Because the formula to calculate momentum, let's go back to this definition here in a straight line. It is just the product of object's velocity and mass. So P is equal to mass times velocity. So if the mass will have a lot of magnitude, or heavier the object, the higher its momentum. And the faster the object moves, the higher its momentum. Okay, and remember, impulse is change with momentum, or in other books, it it discusses as a change in momentum. So the amount of force applied in a very short time, it can affect the momentum, because impulse is just a change in momentum. Okay, so we also have a theorem involved, and we call it impulse momentum theorem. So it talks about the relationship between impulse and momentum. Remember, impulse is just the change in momentum. So they are quite related to each other. Okay, before I forgot, the unit to our two variables this moment, remember, momentum is equal to mass times velocity, and mass in standard unit, that's kilogram, and velocity is meter per second. So our unit will be kilogram meter per second. For impulse, it's the force multiplied by very short or quick time. Force is Newton, and then time is second. So we'll have Newton second as the unit of impulse. But yeah, they are related, so they must have the same unit. Try to look at it. Newton is written as kilogram meter per second squared multiplied by seconds. So seconds will be cancelled. Seconds will be cancelled as well. So if you notice, same unit. Let's talk about the theorem, impulse momentum theorem. When a force is acting on an object in time, in a very quick time, it results to change in momentum. So the impulse results to change in momentum of the object. Momentum is like, we usually use the word momentum if ever we are doing something that we are invested so much, and then someone will disturb us, and yeah, the momentum will be gone. So just like that, the object is moving, and then if it's having a very high amount of mass, it's very hard to stop that object. Really relating to the laws of Newton about motion. And yeah, we can say that impulse will result to change in momentum. So this is a very important equation in our theorem at this moment. Okay, and we can break it down into this: force times time. That's the formula to get the impulse, and we have change in momentum. Remember, momentum is mv final. Change means minus the initial. Or we can break it down into this. Since mass will not change, so mass is constant, we can factor it out. Vf minus Vi. Please take note on this formula. Okay, so let's deal with problem from basic to a little complex. Now we have this very basic problem about impulse momentum. A 1,500 kilogram vehicle is moving, so it has momentum actually, because it moves the mass in motion, if we could still recall. And then the direction of the momentum will follow the direction of velocity. Please take note, because I forgot to discuss it a while ago. Direction of momentum depends on the velocity. For example, if the object moves 2 meters per second and that's positive, so it goes to the right or up, our momentum also will be positive. The value of our momentum is positive. Otherwise, if ever that our velocity is going left or downwards, so we can say it's negative 9 meter per second, that's the velocity. And of course, we will have a negative momentum also. Please take note. Let's solve this simple problem. The velocity of that moving vehicle, it's 22 meter per second, and it's very clear it's positive, so our momentum will be positive as well. So let's figure out P, or the momentum. Remember, it's a mass in motion, so momentum is just mass times the velocity. Mass is 1,500 kilogram, and then velocity is 22 positive meter per second. Momentum of the car, it's 1,500 times 22 meter per second, 33,000, and the unit will be kilogram meter per second. So our next problem, we have same vehicle that we analyzed earlier. So the vehicle weighs 5 kilograms, and the velocity earlier is around 22, but this time it might change, but the vehicle itself is still 1,500 kilogram, moving with the velocity of 21 meter per second, hits a horse. Okay, but the horse this time is not injured, it's just being hit by the vehicle, and then the horse like continues to walk along the road. Okay, so the horse, according to third law, when there's an action, there is a reaction in opposite direction. So the horse applies an average force of 87,000 newtons for this very quick time to the vehicle in a direction opposite to its motion. Its motion, the vehicle's motion. 87 newtons being applied for zero point 0.3 seconds by the horse to the vehicle in opposite direction. That's a third law. Let's figure out the I, or the impulse, because we have force here in a very quick time caused by the horse to the vehicle. And remember, when force is applied in an interval of time, it will cause the momentum to change. Okay, and then what is the velocity of the vehicle after hitting the horse? Okay, so we have two problems to solve this time. So we have our given, so that I will not forget. The initial velocity of the vehicle is 21 meter per second. The mass of our vehicle is 1,500 kilograms. Force of 87 87,000 newtons. This is the force I applied to the vehicle by the horse. Then the time interval is 0.30 seconds. Because we're through, let's get the impulse. Impulse is force times time. So the force is 87. Then we will be multiplying it by 0.30 seconds. The product, hold on, 87,000 times 0.30 seconds. The impulse will be 26,100, and the unit Newton seconds. That's the impulse. This is the amount of impulse that will change the momentum of the vehicle. Now, let's talk about, hold on. We need to consider that that impulse is a vector, right? So in this case, the the force applied to the vehicle is opposite to the vehicle's direction. The velocity of the vehicle is positive, so this force applied should be negative. Okay, so 87,000 newtons negative, it will result to negative 26,100 Newton seconds. That's the amount of impulse that will change the momentum of the vehicle. Remember, this is just direction of the horse force applied. Let's use the theorem to get the final velocity of our vehicle being hit by the horse. Let's do it. So the theorem tells that the impulse is just the change in momentum. So impulse, we know the value of impulse done by the horse. It's gonna be negative 26 1000. It's this value. Don't forget the unit, Newton seconds equals the change in momentum. The mass will not change, so we have to factor it out. Okay, let's copy this one. The mass of our vehicle is 1,500 kilogram, and we need to find the final velocity of it. We have the initial velocity. It's positive 21 meter per second. Let's copy. So 1,000, let's distribute this one, 1,500 kilogram times the unknown minus 1,500 times 21. The answer will be 3,1,500 kilogram meter per second. Then these two units are the same. So all we have to do is to add 31,500 kilogram meter per second, and then we will add it both sides as well to cancel this term, or like saying transpose to the other side. Okay, and yeah, let's simplify. Let's copy 1,5 kilogram and our unknown VF. Then we will try to they have different signs, negative and positive. So let's just input it in your calculator. So 3,1,500 positive minus 26,100. 26,100. So the answer will be 5,400 kilogram meter per second. We're not yet done, and I don't have enough space. Try to focus. I will transfer this remaining figure here. 5,4 kilogram meter per second is equal to 1,500 kilogram and our unknown, the VF. In order to isolate VF, we need to divide both sides by 1,500 kilogram. 1,500 kilogram cancel, so our VF will be the quotient of 5,400 divided by 1,5. So the answer is 3.6 meter per second. Cancel, cancel. So we have meter per second. This is the final velocity of the vehicle. Let's say we have this floor here, frictionless, and we have a 40 kilogram mass here, and there's a force applied of a 100 Newton. And this object is moving at an initial velocity of 9 meter per second. And this object is moving already before before the 100 Newton is being applied, before newtons um is being applied. Again, this 40 kilogram mass is already having its momentum, and then something or someone applied a 100 Newton force to it. And of course, this motion is going to this direction since we have positive 9 meter per second. So I want you to figure out the following: the impulse, the change in momentum, the final momentum, and the final velocity. Remember, these two variable, impulse is equal to change in momentum. So whatever the value of this will be the value of this. So we can just solve for one variable here. Let's proceed. Let's get first the impulse. Impulse is force times change in time. Okay, I forgot to put the time here. The whole system just happened in 4 seconds. So we have the time. Sorry. So the force is 100 Newton times 4 seconds. The answer will be 400 Newton seconds. Let's try to prove later on as we will calculate the final velocity or even the final momentum that I is equal to change in momentum according to the theorem. Next, we need to find the change in momentum. Let's go back to this equation. Since we have 400 Newton seconds, this is also the change in momentum because they are just equal. So, but yeah, let's try to find the final velocity using the theorem. Impulse is equal to change in momentum. So impulse is force times time. We already calculated it over here, so we can plug in 400 Newton seconds. And the change in momentum, mass is 40 kilogram. Then our final velocities are unknown. Initial velocity is 9 meter per second. So 40 kilogram times our unknown minus 40 times 9. The answer is 360 kilogram meter per second. And 400, sorry, Newton per second. Again and again, these two units are definitely same, so we can combine these terms, or we can add 360 kilogram meter per second, both sides, plus 360 kilogram meter per second. So cancel. We have 40 kilogram, the unknown, and then plus 400. So we can have kilogram meter per second, 0.6760. To isolate VF, divide both sides by 40 kilograms. Cancel the mass unit. VF divided by 760 divided by 40 will have 19 meter per second. So this will be the final velocity. So we have the final velocity. I will just put some numbers here. If we have the final velocity, we can calculate the final momentum. The final momentum is, remember, momentum is just mass times velocity final, of course. So the mass is 40 kilogram times our final velocity, we just calculated it, 19 meter per second. 40 times 19, it's 760 kilogram meter per second. There you go. Our final momentum. And try to prove that this one and two equations are correct. We should come up with 400 Newton seconds to get the change in momentum. Change in momentum. Uh-huh. So let's do it this way. Change in momentum is equal to m final minus initial velocity, 40 kilogram, and the final velocity is 19 meter per second minus the initial velocity of 9 meter per second, 40 kilogram, and we have 10, 19 minus 9, 10 meter per second. The answer will be 400 kilogram meter per second. Just the same. So another problem, before we will answer this one, of course, don't forget to hit that subscribe button there if somehow this content helps you. Okay, so we have a force of 100 Newton is used to move a 40 kilogram object for 5 seconds. It's definitely, we need to find the impulse of it. We have the force and then the time. Then the object initially moves, so it has momentum because it's moving with that mass, initially 15 meter per second. Let's figure out the impulse expended on the object and the final momentum. Let's begin with impulse. Impulse is force times a change in time. Force is 100 Newton times the time for 5 seconds. The answer will be 500 Newton seconds. This is the impulse. Let's look at the direction. Okay, it's positive. Now, let's have the final momentum. We can find the final momentum by using the theorem. Okay, so impulse is equal to change in momentum. The impulse we just calculated here, 500 Newton seconds, and the change in momentum, we can do it like this, E final and P initial. We need to find P initial. M mass times initial velocity. So the mass is 40 kilogram and the initial velocity is 15 meter per second. 40 times 1.5, it's 600 kilogram meter per second. So let's put this value here. So we can have 600 kilogram meter per second. These two units are definitely the same, so we can combine them. Or let's add 600 both sides, or transpose. It's okay. So it will be cancelled, leaving the final velocity. So 500 plus 600, that's gonna be 1,100 Newton seconds. Our final momentum is 1,100 Newton per second. To prove that our answer is correct, remember impulse, it's the change in momentum. So the impulse that we calculated is 500. Yeah. So final momentum minus initial momentum, 500. The final momentum, it's 1100 minus the initial momentum, 600. Our answer is 500. Same.